With our wiring harness completed, we can now work on the final bits of assembly. I went ahead and whipped up this quick mount for the CT22 display using some bent sheet metal. Sheet metal is pretty easy to cut and bend, and while it isn't the prettiest mount, it works fine. And if you wanted something nicer, you could 3D print something or buy a mount online. I also couldn't find the seat post clamp that I believe came with the frame, so I grabbed one off Amazon, and now we can install the seat. On our left handlebar, we've got a switch cluster, a brake, and our regen lever. Let's go with the switch cluster first, then our regen lever. Next, let's do the left brake. The brakes need to be installed right side up so you can bleed them. This screw in the label indicates the top. Unfortunately, the brakes were shipped with the caliper already attached to the left brake. Since the left is my rear brake, I'll have to undo this. Let's mount it for now. And let's throw the left grip on too. Now for the right side, let's start with the headlight switch. Then we'll do the brake, then the 3-speed, and the throttle. So with everything mounted to the handlebars, I'd like to be able to run the brake lines. However, for some reason, the brakes came with the brake caliper already connected to the front left brake. In my world, the left is the rear brake. So I have to undo the rear brake and reassemble the front brake in order to mount them. I'm gonna pull the cover off the front left brake, and I'm gonna rotate this so it's high up and pretty level. And they do give us a kit of tools, so I'll grab the wrench, and I'm gonna unscrew this. Cool. And I'll move this to the right lever, which will be my front brake. Do not squeeze the brake levers when the brake hose is not attached. Cool, we now have a caliper on the right brake. Now I'm gonna grab the rear brake and run it through the body of the bike. This brake hose, even though it's not connected to anything right now, already has fluid in it. And there's a small screw at the top keeping it in. So the rear brake is gonna run from back here, all the way up the bike, through this hole here, and up to the front. The bike comes with a few of these O-rings to protect the wires going through these holes. So this will go down here, and the brake hose will go through it. But before we do that, we also have to run the motor cable through there. And that doesn't quite fit, so we'll need to de-pin the connector. Take some photos with your phone so you remember where the wires go, and start popping them out with the screwdriver. The pins are hot glued, so I'm using some isopropyl to loosen it. All right, this is done so it can fit through the frame. And while we're deep pinning connectors, we got this guy, the hall sensor for the controller side of things. With the connectors depinned, everything can now fit through this ring. So we can feed all those cables through the hole in the frame. I routed the motor cable up through the frame and the brake up next to it. And I pulled the brake hose out the front. Now I'll pull all the controller wires into the frame through another gasket O-ring. With all those wires in there, as space starts to fill up in the frame, I realize it's a good idea to put our USB port in before the inside of the frame gets even more full. I've got a drill with a step bit and a paper cup. I'll use the paper cup to catch any metal dust falling into the frame. We'll take the USB port and then the moisture cover, and we'll grab one of the nuts that it comes with and then tighten the nut from the other side. With that done, I'm gonna go ahead and repin the connectors that we depinned a minute ago. So I went ahead and repinned the connectors, and I connected one of the hall sensor wires to the controller. I would have liked to have filmed more, but it's really tight in there. Basically, you just put the pins back where they were and connect the wires. Now I'm gonna mount the rear brake. We'll be using this brake adapter. Mount the brake adapter to the swing arm in this orientation. Take the rear brake and mount it into place. The way the calipers ship, they're in their open position. In their open position, they should not touch the brake rotor. There should be a little space on either side. If you don't get the alignment right now, don't worry about it. We'll come back to it once we have the brake lever installed. It'll make it easier. Now I'm gonna zip tie the brake hose and the motor wire to the swing arm. Next, I'm gonna go ahead and run all the cables from the handlebar into the frame through the same hole the brake tube is coming out of. I'm also gonna mount the horn up top and run that wire through as well. Those cables fit through pretty well. Now I'm gonna grab our main wiring harness and make sure we can fit those cables out as well. Unfortunately, it looks like I need to drill another hole for the battery cables. I'm gonna drill from the outside with a vacuum on the inside. Let's pull the turn signal cables and the headlight cable through the hole in the front of the frame. And while we're at it, let's route the other turn signals through the hole in the back of the frame. With everything on the bike now routed where it needs to go, we can just start plugging in all the connectors on the harness. Let's save the battery for last though. I connected everything except for the battery and the key switch. So let's pop that in. Let's plug in the headlight now and put heat shrink over every connector. We don't want to turn the bike on with all these loose wires. Now I'm going to mount the turn signals. The front signals are white for DRL, yellow for signal, and black for ground. The rear signals are red for brake light, yellow for signal, and black for ground. We can use the headlight bracket to mount the front signals. Now I'll do the rear. I'm going to drill 2 holes in the seat mount back here. Now I'll plug in all the turn signals and heat shrink over the connectors. I'll also heat shrink over the headlight connectors. And let's give them a test. DRLs light up. Let's check left front, right front, hazards. Check the rear, left rear, right rear, hazards. And we'll check the brake that does have the hydraulic hose connected. Remember, don't squeeze the other one. The last electrical component for me to check is my phone charger. And we're charging. I'm still waiting on the front brake adapter in the mail, but there's a lot I can do in the meantime. I ran the battery charge connector out the same hole as the rear turn signals. I'd like to start programming the Saviton controller. However, I want to make sure that my rear brake is set up so I can stop the motor if I need to. So let's do that quickly. Our brake line is a small screw in the top. First, let's slide the sleeve over. Then let's unscrew this piece from the brake lever. Remove the guard and place the cover back there. Now let's unscrew the screw, careful not to spill. Grab this piece, throw it in, screw this in. And if we squeeze the brake now, our rear brake works. Let's throw the cover over. Okay, I've propped up the rear wheel on some boxes so it can spin freely. And now I've got my laptop out to start programming the Saviton. There is a phone app and a USB Bluetooth adapter, and that works pretty good for most things, but not everything. For example, our regen lever does not work properly if we just use the phone app. All right, so we'll program the Saviton controller now. You'll need to install the MQCon app as well as the driver. I'll have links to that below. So turn on the bike and plug it into your computer with a USB adapter they include. And let's open MQCon. The app looks like this, it's terrible. Under the communication tab, you need to manually set the port. You can tell you're connected by the fact that these lights are blinking and it's giving you a system status. All your settings are up here. Let's go to set. The first thing we're gonna do is head over to the motor tab. Our motor spins backwards by default. If you bought the same motor as me, chances are it'll spin backwards too. I'm gonna set this to 1, which reverses the direction, and hit OK. All right, motor PN. That should say motor pole pair numbers. How many pole pairs are in the motor? You can Google this based on the type of motor you have. The QS205 that we have is 16. Okay. Speed limit mode. We don't want to limit. Don't worry, this will still allow eco and sport mode. Keep the limit at no limit. Set this to 100. I don't know if that does anything, but I always set it to 100 anyway. Low speed, we'll keep it 45%, and mid speed, we'll keep it 85%. So normal and eco mode will still work, but sport will have no limit. Next, let's head over to the debug tab, parameter store. Current loop KP. That is, I believe, a tuning gain for a Hall sensor detection that we need to run right now. We don't ever need to touch that number. So let's talk a little bit about the Hall sensor detection. The speed controller, the Saviton, needs to know where the Hall sensors are and how they're oriented so it can spin the motor properly. Let's set this angle here to 120 degrees. Again, that's something per motor specification that you can Google if you're using a different motor, but the QS205 is 120. Test current. How much current can the motor use for the Hall test? 10 is usually fine. Control mode, Hall test, okay. And finally, enable Hall test and click OK. And the motor starts moving. It's going very slowly, but it is moving. We'll let it run its course. Sometimes it makes some quiet noises, but the important thing is to make sure the motor has no resistance to it and that it's propped up on something so it can spin freely. This takes around 60 seconds. After the motor stops moving, the Hall test is successful, so we need to power cycle. So close out of settings, it says test OK here. We'll hit quit, then we'll unplug the bike, turn the bike off, wait a couple seconds, bike on, wait a couple seconds, plug in, and then open up MQCon again, and then connect again. Next, let's go to our function tab. And the next thing we're gonna do is try to get our variable regen working. So from eBrake, we'll hit eBrake throttle, hit OK, debug, parameter store. Wait a few seconds, close settings, quit, unplug, turn off, turn on, and spin the wheel. Goes the right way, and we've got our regen throttle working. Great. Something to check now is to make sure the motor power is cut when we're using any of the brakes. Left brake, no power. Lever, no power. Right brake, no power. Great. Let's plug back in. Let's go back to the function menu because we just clicked on a setting there, but we didn't go through what all them mean. So e-brake mode, throttle or switch. That's whether we want to use the brake lever for braking, just like an on and off, or whether we want to use a variable regen lever, which we have set. E-brake phase current. How much phase current are we using to brake? 50 is fine. Boost or 3-speed. The Saviton has an option to use the 3-speed switch as a boost button. We're gonna use the 3-speed switch because the boost button doesn't actually do anything special or make the controller go past its limits. It's pretty useless. Cruise enable, doesn't matter. Reverse percent doesn't matter. Flux weakening. All right, so if you'll recall earlier, we talked about how motors are rated in kV, or revolutions per minute per volt. Basically what that means is your battery's voltage directly correlates to how fast the motor spins. In fact, your motor's speed limit is determined by its voltage. At a certain point, a motor can't spin any faster due to the limitation of the voltage. Well, kind of. The magnetic field of your motor actually gives it some resistance too. So if you could take away that resistance by weakening that magnetic field, your motor could go a little faster. You gain another 5 or 10 on the top end. This is called field weakening. Basically, by pushing tons of current into the motor, we can destabilize the magnetic field and lessen the resistance to the motor, letting it spin a little faster. This is at the expense of lots of battery current and lots of heat to the motor. We'll keep it on, because going fast is cool. Regen charge will enable this. This lets the power from the regen actually go to the battery. Hit OK, slide regen. Slide regen is how much regen is the controller doing when you're doing nothing. So if you go forward and then you let off the throttle, does it start braking, and if so, by how much? I don't like having that. Some people like having that. I think Teslas kind of drive like that. If you want, you can play with the setting, but I'll leave it. So we'll save all these settings. We'll go to the debug tab, hit parameter store, wait a few seconds, set, quit, unplug, turn off, turn on. Then we'll plug back in, and this will be our last round of settings here. All right, let's go to our basic settings. So lack volt, right? That's when does the controller shut off because its voltage is too low. If you remember earlier, we talked about the fact that lithium batteries should not go below 3 volts per cell. Since this battery has 20 cells in series, the absolute minimum voltage for this battery is 60. I'm gonna give that a little safety margin and set this to 63. Overvolt. We're not gonna touch this. Our BMS has an overvoltage protection. DC current, how much current can we pull from the battery? 100's plenty. Boost DC current, we're not using boost. All right, phase current. So your DC current is consistent. Say you're pulling 20 amps from the battery. That's a consistent 20 amp, constant draw. Your motor is not using power that way. Now, if you'll recall, we talked about earlier how your motor actually gets power in pulses. Power is being sent to a set of windings, one set at a time, alternating really quickly which set has the power. The result of that is that the motor phase current is not the same as the battery current. Anyway, our controller limits these settings for us anyway at 120, 260, and 350. Rated phase current is how much can it take forever. Max phase current is how much can it take in bursts. And protective phase current is when does the controller shut off because there's too much power. Temperature sensor. Let's click enable and OK. We'll go down here and we'll set this to 90, 80, and 70. We'll hit OK, OK, OK. And what this means is if the motor reaches 70 degrees Celsius, the speed controller will limit current to it in order to keep it from overheating. If somehow it reaches 90 Celsius, it'll totally shut off, and it won't turn back on until it reaches 80 Celsius or cooler. Now let's check out the throttle tab. All right, so here are our throttle settings. We've got minimum voltage and maximum voltage. Now, I told you earlier a throttle goes from 0 to 5 volts. That was a little bit of an oversimplification. Usually the top of the throttle ends at like 4.6, 4.7, sometimes 4.8 volts. And the bottom of the throttle, we want to have some deadband too, right? We don't want anything to happen for a small amount of range of motion, because otherwise it would be too easy to move the bike. So I'm gonna keep that at 1.3. I'll keep that at 4.4 and that's fine. Accelerate time and decelerate time. I'm gonna keep these stock, but basically it's how fast does your throttle input actually affect the bike's motor. Like if you pin the throttle, how long does the controller take before it actually gives the motor full power? You can set it as low as you want. Your front end will be up all day. Just be safe. Throttle mid voltage, not gonna touch that. That helps you change your throttle curve. And what is your mid current at the throttle mid voltage? I don't actually think this does anything, and I'm just gonna leave it. I've always left it stock, and I don't wanna mess with it. Now we'll go to the debug tab and hit parameters store, and that will save everything to our bike. Unplug, turn off, turn on, and we're done programming. I'm still waiting on the front brake adapter. I think that's probably the last thing I'll do. But for now, I can close up the bike and neaten up all the wires. Let's set the CT22 display settings. There's two buttons on the side. If I hold the bottom one down and turn the bike on, it's gonna ask us for a password to enter settings mode. The password to enter here is 6610. Long press to set, short press to increment. Long press to set. Cool. We're now in our settings menu. Right now, this is set to 142, and we need to set it to 157. Let's explain why. This setting here is a frequency. It is 142 Hertz. That corresponds to 60 kilometers an hour per the display manual. Do you guys remember the hall wire we connected to the speedometer? The motor has 3 hall sensors, but we only pass one of those along to the display. That hall sensor gets 16 pulses every time the motor spins 1 revolution because the motor has 16 pole pairs. Every time the hall sensor passes over a pole pair, we get a tick. So with 16 pole pairs, we get 16 ticks every time the motor spins 1 revolution. So this setting here, this frequency corresponds to 60 kilometers an hour. The display right now has the number set to 142 Hertz. So right now it's set to output 60 kilometers an hour if it's getting 142 ticks per second. That number is pretty accurate for a 17-inch wheel, but we have 19-inch wheels. And when we measure with the tire, we actually get around 24.5 inches to the ground. So let's do some math quickly. 60 kilometers an hour is 16.67 meters per second. With the 24.5-inch wheel, our circumference of the wheel is 1.695-ish meters. So how many rotations per second are we doing at 60 kilometers an hour? 16.67 divided by 1.695 is 9.83 revolutions per second. So with this bike actually doing 60 kilometers an hour, the wheel's spinning 9.83 times per second. If we know each spin of the motor gives us 16 ticks, and we're doing 9.83 spins of the motor per second to keep us at 60 kilometers an hour, then we're getting 157.2 ticks per second. So in short, with this bike actually doing 60 kilometers an hour, one hall sensor outputs 157.2 Hertz. We're gonna set this number to 157 so that the speedometer readout is accurate. Long press to enter the settings. Short press to change. With that stored, short press to go to the next setting. This setting is exactly the same as the last one, but it's for the odometer and not for the miles per hour readout. We should set it exactly the same. My wheel is visually not square, so I'm going to adjust that. The small nuts need to come off fully because these need to go on first anyway. I'm going to leave these loose for a little longer because we can put the crankset on and slide the wheel to a point where the chain has tension. That looks like it's actually just right. I'm going to work the wheel as far forward as I can to try to make that line up. Since it looks exactly the right length, I'm just gonna loop it over here. Since it looks like it's the right length, I'm just gonna do the master link here. And we'll throw that on. With over here, I'll just lay that down and mount that up. Since I know this length is really close to perfect, but I don't have a chain tensioner, what I'll do is pull this off, push the wheel back a tiny bit, lock it down, and then place this back on to keep the chain tight. Make sure both sides of the axle get 2 bolts. Also, lock down those torque arms. These metal plates keep the wheel from spinning itself out. There's a lot of torque there, so you gotta make sure it's tightened down proper. Let's mount the other crank arm and the pedals. All right, it's officially a bicycle. All it needs is a 750 watt sticker and we're good to go. I finally got in my brake adapter. And after making sure the wheel spins freely and there's no friction on the rotor, we'll put some air in the tires and take it for a test drive. I pumped up the tires to 35 PSI, zip tied the new brake line into place, and replaced the seat clamp with the one that came with the frame. Let's take this thing for a spin.